Hi class, here's our first video lesson for Chapter 8, 8.1 Angles of Polygons. Let's refresh ourselves on the several kinds of polygons that there are. A concave polygon, you guys could maybe draw these in your notes as some examples. A concave polygon is where at least one vertex is pointed in. Like in towards the shape. So like this vertex right here is pointing in towards the shape. If you were to like extend this line, it would go through the shape. Same thing with like this vertex and this vertex. They're pointed in. If you were to extend this line, it would keep on extending out. If you were to extend this one though, it would extend in towards the shape. So that vertex is pointed in. Same thing with this star right here. I guess more technically speaking, it's a decagon because it has 10 sides. But again, at least one vertex is pointed in. This one has 5 vertices that are pointed in. Whereas a convex polygon, here are some examples of convex polygons. It is where all vertices are pointed out. So none of the vertices are pointed in towards the shape. If you were to extend all of these lines, none of them would go through the shape. All of these vertices are pointed out. If you were to extend all of these lines, none of them would go through the middle of the shape. Okay, so that's the difference between a concave and a convex polygon. In a way, this concave, like there's a cave. If you kind of think about like this part right here, that vertex is kind of like a cave. Right here, it's an inlet, it's a cave, so to speak. So that's kind of the difference between those two. A regular polygon are where all sides are congruent and all angles are congruent. So all the sides are the exact same length, all the angles are the exact same degree measure. So the regular polygons, they're always going to be convex. All the vertices will be pointed out. But again, it's even a more specific type of convex polygon. All of the sides are congruent. All of the angles are congruent. So in all of these, if you want to put like a tick mark at all of them and an arc at all the angles, they're all going to be the exact same length. The sides will be. And all the angles will be the exact same degree measure. Okay, so that's a regular polygon. So now we're going to talk about the angles. Like I think we've got this triangle down. All of the angles are 60 degrees because 60 plus 60 plus 60 is 180. But how about this one? How many degrees are in that one? How about this one? How many degrees are in that one? That's what we're going to discover right now. So I have these up here. And a triangle, of course, has 3 sides, right? That's not anything too complex just yet. The sum of the interior angles in a regular polygon, in a regular triangle, all 3 of these are 60, right? And so we say that there are 180 degrees in a triangle. So the sum of the interior angles is 180 degrees. So how about the quadrilateral? Well, a quadrilateral has 4 sides. Now just think with me here for a moment. You guys probably already know this one. But if I were to draw a diagonal from here to here, how many triangles does that make? Well, hopefully you see that there is one triangle right here that has 180 degrees in it. And there is one triangle here that has 180 degrees in it. So as far as the sum of the interior angles, wouldn't you say it's 180 plus 180? And that would be 360. And again, you probably maybe have heard that before. In a quadrilateral, there are 360 degrees. So how about a pentagon? Well, let's take that same rationale, that same strategy. I'm going to draw a triangle right there. So there's one triangle. It has 180 degrees in it. Here's another triangle. This triangle has 180 degrees. And here is this triangle. And it has 180 degrees. So a pentagon has 5 sides, and the sum of the interior angles is 180 plus 180 plus 180, or 180 times 3, which is 540. let's do this one more time, shall we? How many triangles can we make in a hexagon? There's 1. There's 2. There's 3. And here is 4. There is 1, 2, 3, 4 different triangles that we can make with a 6-sided figure, a hexagon. So 180 times 4 is 720 degrees. So if there are 3 sides, there is 1 triangle. If there's 4 sides, there's 2 triangles. If there's 5 sides, there's 3 triangles. If there are 6 sides, there are 4 triangles. So what if there are 7 sides? Right? If there's 7 sides, wouldn't it make 5 triangles? And 8 would make 6 triangles, and 9 would make 7 triangles, and 10 would make 8 triangles, right? It's always 2 less. And so if there's 5 triangles, then you'd multiply it by 180. If there were 6 triangles, you'd multiply it by 180. If there are 7 triangles, multiply it by 180. 8 triangles, you multiply it by 180, right? So we get this formula. For the sum of the interior angles, what you do is you take the number of sides and you subtract 2. Because that's how many triangles you'd get. And then that many triangles, you multiply it by 180 degrees, and bang, you have the sum of the interior angles. So 180 times n minus 2. That's how you get the total of all the interior angles of a convex polygon. Whew, crazy, right? So now if I want to find just one of those angles, like what if it was a square, right? Well, you guys probably know that in a square, all the angles are 90. There are 360 degrees, and we would divide that by the number of angles that there are. We would divide by 4. So if this is the sum of the interior angles, where n is the number of sides, or angles, because it would be the same, if I wanted to find just one of them, I would divide by how many sides that there are. So in our formula, we would divide by n. 180 times n minus 2 divided by the number of sides that there are, n. So those 2 formulas we're going to be using here in just a moment. Let's also talk about the exterior angle sum theorem. The exterior angle, so like all of these are interior angles, and in a regular polygon they're all congruent. The exterior angle would be if I were to extend one of these segments, this right here would be the exterior angle. Or this one right here would be the exterior angle. Okay? If you add up all the exterior angles, you get 360 degrees. So if you add up all those exterior angles, it kind of makes like a circle. If you were to, a circle has 360 degrees, you add up all these, you'd get 360. So if I wanted to find just one, just like on the sum of the interior angles, you would divide by the number of sides that there are. So to find one exterior angle, you would take 360 and divide it by the number of sides that there are. So 360 divided by n. Let's now try this one where we want to find the sum, or the interior angle and one exterior angle of an octagon. Find the measure of the 2 numbered angles of the regular octagon. So here is the work for number 1, and I'll do the work for number 2 right over here. So is 1 an interior angle or is it an exterior angle? Angle 1 is an is an exterior angle. So the formula that we're going to use is 360 divided by n. So how many sides are there? We talked about how this is an octagon. 1, 2, 3, 4, 5, 6, 7, 8. So 360 divided by 8. So angle 1 is, when you take 360 and divide it by 8, you get 45 degrees. 45 degrees. Angle 2 is an interior angle, isn't it? So if we want to find the sum of all of the degrees of a regular octagon, it's 180 times n minus 2. And n in this case is 8, because there's 8 sides. But if we want to find just one angle, which angle 2 is just one angle, I want to find out how many degrees that is, we would divide by the number of sides that there are. Divide by 8. So it's 180 times 6 divided by 8. 180 times 6 and then divided by 8, you would get angle 2 to equal 135 degrees. And that's saying that, being that this is a regular octagon, this is 135, this is 135, this is 135. All of these angles that are on the interior are 135. So is it kind of interesting? To me it is, anyway, I don't know about what you think. This is 135, and angle 2 is 45. What do you notice about angle 1 and angle 2? What's 135 plus 45? 180. They are supplementary, which they should be, right? Because they form a linear pair. They form a line right here. All right, let's try another one. Find the number of sides and the number of angles of a regular polygon if the measure of one interior angle is 150. So this time I'm solving for a different variable. I want to find the number of sides and the number of angles, which again is going to be the same. If a pentagon has 5 sides, it has 5 angles. If an octagon has 8 sides, it also has 8 angles, right? So the sum of one interior angle, or to find one interior angle, it's 180 times n minus 2 divided by n. This time, I don't know how many sides it has. That's what I want to find. But I do know one interior angle is 150. So 150 goes into that spot. So I'm going to set up this equation, 150, that equals 180 times n minus 2 divided by n. And we're going to solve for n. Here we go, everybody. Let's first get rid of the denominator. We're going to multiply both sides by n. Hiya. Multiply this by n. So we get 150 multiplied by n. That equals, I'm going to distribute this 180. So 180 times n is 180n. 180 times a negative 2 is a negative 360. I continue solving for n. I subtract 180n to get all my n's together. And here I get a negative 30n equals a negative 360. And then I divide both sides by a negative 30. And I get how many sides this figure has. And when I take a negative 360 divided by a negative 30, I get 12 sides. So this figure with an interior angle of 150 is a dodecagon, a 12-sided figure. Okay, last one for the day. I want to find the value of x. Well, if I look at this, I would have to kind of basically know how many degrees are in this figure, and then I could add all of them up and set it equal to that many degrees. So how many sides does this thing have? 1, 2, 3, 4, 5. This is a 5-sided figure. We call that a pentagon. So how many degrees are there in a pentagon? Well, we have it in our notes, but if you ever didn't have it in your notes, you could say, well, the sum of the interior angles of a pentagon is 180 times n minus 2. Oh, I was going to say divided by n, but we don't want to find just one. We want to find how many degrees are in the whole thing. So it's 180 times n minus 2. So how many degrees are in this pentagon? 180 times 3. And 180 times 3 is 540. So what we're saying now is that if we take this plus this plus this plus this plus this, and we add them all together, we're going to get 540 degrees. And now we can solve for x. So we have angle x plus angle x plus 20 plus angle x plus 5 plus angle x minus 5 plus angle x plus 10 equals 540 degrees. I ran out of room. Sorry about that. Hopefully you guys don't run out of room. All right, let's combine like terms. 1, 2, 3, 4, 5 x's. Let's see, 20, 25, 20, 30. Plus 30.
Please dismiss to block 2 at this time. Thank you.
Equals 540. So I subtract 30 from both sides. And I get 5x equals 510. I divide both sides by 5. So 510 divided by 5 is 102. x equals 102. And that's my answer. If I wanted to find the value of all these angles, I could substitute x back in. But this one asked me to stop at x, which is 102. Let me know if you have any questions on that when you get to class tomorrow.